Yeah?
Yep.
Okay. We are beginning with your talk. Uh, please talk about a little about you, um, and that's it. Please.
Uh, okay. Hi.
Pueden
Hi.
subirle.
Welcome to this talk about deep learning at Booking.com. A little bit about myself. I am Sahil Dua. I work at Booking.com, and let me talk about what I am and what I'm not, so that we have expectations set right. So I work at Booking.com as a backend developer, and I'm building deep learning infrastructure right now. I'm also a machine learning enthusiast, which brings me at the perfect place for where I am right now, like backend as well as the machine learning combination. Next, I'm also open source contributor various projects. Like I've contributed to Git project, which probably all of you use at almost daily. I'm also contributing in Pandas library, which is a Python library for data analysis. And I'm also a tech speaker. As you can see, I'm giving this talk, and I love talking about technology in general. So let's talk about what I'm not. So I'm not a data scientist, and I'm not a machine learning expert, which means that if you have some particular detailed doubts about machine learning or deep learning, I may not be able to have the best answers, but I will definitely have good references for you, or have all your questions about deep learning infrastructure answered. So let's talk about what we are going to cover today. First of all, I'm going to talk about when you should be using deep learning. Like it's not that deep learning should be used everywhere and in all the problems. Next, I will talk about how we use deep learning on images at Booking.com. How we utilize deep learning, uh, for example, convolutional neural networks to make sense of images. I will also talk about the wide and deep network combination. These are the new type of networks which are introduced by Google recently, and I will talk about how we can make use of these and how these help over the general deep learning. Next, we'll talk about the models in production, which is like once you have the models on your laptop, once you train your model, now you're ready to serve predictions. But how do you go about putting your model in production? And at our scale, we have millions of users every day, and I'll talk about what strategies we are using to make sure that we are running up 24/7. So first of all, before I start, I would like to acknowledge the efforts of Emra and Stas. These are the other two team members working on deep learning, and these are the two guys who actually started the entire deep learning thing at Booking.com, and they are the ones who actually worked on most of the stuff that I'm going to talk about in this presentation. So thanks to them, and let's begin. So when we talk about deep learning, Imra used to tell me a story that whenever there are a lot of times that people come to interviews and they start using deep learning on even simple problems, but that's not the case. Like there are some problems in which you can just use logistic regression or other simpler techniques to get good results, and there are some things where deep learning is just going to waste your time, and you should not be doing deep learning. But let me talk about some of the very famous applications of deep learning where we have seen tremendous improvement by applying deep learning. First of all, when we talk about analyzing image content, we know that images are not uh, seen by the computer as we see by our eyes. Uh, we have seen ImageNet, we have seen tremendous development and in the terms of how we classify the images using ImageNet. We've also seen image captioning or style transfer and also generative adversarial networks. And talking about the analyzing text, we've seen that, for example, machine translation. Google has recently started using deep learning networks for their machine translations, and it's been tremendously good. So that's another area in which deep learning has proven to be a boon. Another thing that we have seen a lot of improvement by using deep learning is understanding and generating speech or from text or vice versa. We have WaveNet, which is similar to ImageNet, but it's for speech, and we have Deep Voice and Technotron, which are again the more advanced architectures which make use of deep learning to make sense of the speech. Next, we have deep and wide models for recommendations. And these are the models which are recently introduced by Google, as I mentioned earlier. And they have announced that they have started using deep and wide networks for their Google Play Store as well as YouTube recommendations. And this provides us a really nice hint that these are some things that we need to explore and may be useful for us at Booking.com as well. So now let's talk about deep learning on images at Booking.com specifically and how we make sense of the images that we have on our website. So first of all, what do we see in these images? This is a really simple question as well as a very difficult one. So, for example, what do you see in these images? We can see a bed, we can see a blanket, we can see a TV, we can see a lamp, ocean, or chair, table, chair and table. And when we pass this particular image through other commercial APIs available for classifying images, we find these results, which says that it's the ocean front, nature, beach house, building, penthouse, apartment, housing, which also makes sense. But at Booking.com, we have a very different data set. What we are looking for are the particular things. For example, what we see in these images at Booking.com using our own networks is this. We see that, okay, it's a sea view, it's a balcony view, it's a photo of the whole room. Yeah, because we can see multiple things in a room, and there's a sitting area because we can see in the balcony there are some chairs and tables. So this is how we cannot just use the ImageNet that is available and use that for our purpose, because what we see in the images is going to be very different from what other people or other companies or other use cases see. So it really depends on the use case. And for us, since we only have pictures, images about hotels, uh, things are really different for us, and we have to customize all the models that we develop on the basis of what we see in the images and what matters for our business. So now that we see this example image, let's talk about what are the challenges that we faced and how we solved those. First of all, as I mentioned, the Booking.com has a very unique corpus, and we don't really have animals unless people travel with their pets. We are not going to see zebra ever unless it's a very weird hotel. Um, yeah, so we can't just use the models which are available using the general data. We have to train these on our own data and find the features that matter for us. And that brings me to the next challenge, which is how do we define these classes? For example, we saw that there is a sea view, there is a bed, there is a photo of the whole room. How do we define what classes we are going to fetch? Why do we not mention that there is a chair? Why don't we mention there is a TV? Or why don't we mention there is a cushion or blanket? What are the things that we care about, and how do we define these classes? How do we define what are the features that we need to extract? This really depends on the business case, like how we how we're going to define the classes that we want and that we want to use in our use cases. So what we do is once we choose proper labels, we train a deep network. Next, there are multiple challenges. Like a single photo is going to have multiple classes. For example, in this case, a photo has 6 classes. And how do we make sure that we are able to classify different images having multiple classes with different probabilities? And then we also need to take care of the error evaluation, how we evaluate the errors on these classifications. Next challenge is how do we define the hierarchy? Like if we know that there's a bed is going to be inside the bedroom, unless again you are in a really weird hotel and bed is outside the bedroom. But let's consider the case when bed is inside the bedroom and the bedroom is going to be indoors. So how do we uh, create the hierarchies of these labels? It was initially it was done manually by considering the different classes and then seeing how they relate to each other. And by defining those hierarchies, we were able to narrow down the classifications to to a brief set of uh, definite set of features. Next is how do we do the accuracy evaluation? How do we measure how well these classifications are? And we are still in process of doing this, and we are still continuously improving, continuously checking how well our accurate evaluations are. Um, so once we have the image classification, once we have trained a deep network which is able to predict and which is able to classify the images, next challenge is how do we scale? How do we scale these models to our scale at which we have more than 200K new images per day? And these there are we also need to have real time predictions. Um, yeah, so these are some of the challenges that we faced while doing the image classification network.com. So this was about how we trained and how we extracted the features. Now let's talk about how do we use this image content. Once we know the embeddings, once we know the features or classes of an image, how can we use this information to make better use for our business? And what we do is this. Let's say you come to booking.com and you are looking for a swimming pool. You select something, select a search in a search result. You select that you want to have a hotel which has swimming pool. And now if we have image classifications which tell us that there are some images which are of swimming pool, we can actually show you more relevant results, and that will increase the probability of you booking a property, as well as it will help you in making a decision quickly because that's something that exactly you are looking for. And similar thing that we do with breakfast buffet as well. There's someone who's looking for breakfast buffet. If we know that there are some images in a particular hotel which are related to breakfast buffet, we can show that hotel to you earlier than other hotels, so that it's easy for you to decide which hotel you want to stay at. And next thing is how do we decide what is right, what is wrong, like whether the tag is right or not. And for this we depend on A/B testing. At Booking.com, we don't really make any decision on our own. We use A/B testing to help us in taking those decisions, because we always want to make sure that we're not going on the basis of assumptions or opinions. So we always use A/B testing to see how our new models or how new classifications are doing, and we take decisions on the basis of the data that we get out of A/B testing. So this is a nice use case for business. Let's say let's say we have different users uploading images to our website, giving reviews about the food. And if we know that a particular photo is about food, we can also suggest to people where they might like to eat tonight. For example, we can create a menu which can be shown on the map, and they can just click on any dot on the map, and they can easily see the pictures of the food at that place, and we can help people in making a decision, making it easy decision about where you want to eat tonight. Uh, Next, let's briefly talk about how to train a deep network. And there are two traditional approaches. One is just training a model from scratch, which, as you can see in the first diagram. The next approach is transfer learning, which is when you train your model on one set of data, and then you transfer that knowledge, that the learned knowledge, to another domain. And that's why it's called transfer learning. So you transfer your learning from one set of data to another, and that helps you in generalizing your learning in a better way. There are other ways as well, like for example, you can use the last layer activations of a deep neural network, and use those activations as features, and use those features to create a support vector machine, and that will like help you in having a better model than what you will get using the traditional method of training from scratch. Or you can also do training a deep network using fine tuning of the network, which means is first you train on a particular model, a particular data, and then you tweak some of the layers on the basis of how you get the feedback on your new predictions. So you keep fine tuning your network on the basis of the feedback. Now, that was all about the images. Let's talk about the recommendation engine use case. So what it means is, let's say we have a user X which booked a hotel Y, and now we have a new user which is Z, and they come to our website, and our task is to choose a hotel that we want to recommend. And of course, we want to recommend a hotel which they may like, which they will like, and we want to recommend a hotel to maximize the chances of them booking that hotel. So basically, it's a supervised learning problem. We have some data about users, X user Y, and we want to see how the behavior will be for a new user. And so our objective is finding the probability of booking a hotel by a particular user. So we are going to have some user features like the country of the user, or what language user is browsing our website in, or we are also going to have some contextual features like what day of the week they are looking for, what the season is, and also we're going to have some hotel related features which are like what's the type of the hotel, it's a 4 star, 5 star, what's the price, what's the location of the hotel, is it in the city center or is it far away from that. So these are the other all the different types of features that we are going to have. So one approach to create a recommendation system is using memorization, using logistic regression. And what that means is we have various features, like we have user features, we have hotel features, and what we do is we create a logistic regression model using these. And what it will help us is it will help us in learning all those features without generalizing. So it will help us in finding out features which are occurring very frequently. And what that means is we have, as you can see on the right side, we have crossed features. What that means is, let's say we know that all the people coming to Amsterdam are looking for hotels which have Wi-Fi. And if we see that this is a pattern and this is something that's been occurring very frequently, we can have this as a crossed feature, which means that all the people looking for Amsterdam will always see hotels with Wi-Fi. So this is like the intersection of two things, two features, and that's what we call a crossed feature. And using logistic regression will help in putting more weight on the cross features, because these are some things which occur frequently, and this is very important while we make a prediction for a new a new property or new user. The other approach can be using a deep network, which means that we are going to have different sparse features, but we're not going to use them directly. We are going to have multiple hidden layers and dense embeddings, and this will help us in generalizing all the features. So this will not help us in putting more weights to those features which occur more frequently, but it will help us in generalizing all those things that we see during training, so that we can easily generalize all those combinations to the examples that we don't see during training. So we have two things now. We have wide models as well as deep models. What if we combine these two? And this is what we get if we combine wide and deep models. And this is what exactly Google presented in their paper. As mentioned, the paper was named "Wide and Deep Learning for Recommender System." And as we can see, there are some features which are being directly used as a part of logistic regression, like which is called the wide model. And there are some features which are used as a part of deep network, which have multiple hidden layers and multiple dense embeddings. And this is the deep part. And when we combine these two, we get the best of the both networks. From wide, we get the memorization, we get the weights to the all the more frequent features, and from the deep we get the generalization. So we get both memorization as well as the generalization using this wide deep network. So now that we have seen that we are getting best of the two worlds, which is memorization and generalization, it leads us to a basic trade-off, which is bias and variance trade-off. Quick definition: bias is the algorithm's tendency to consistently learn the wrong thing by assuming wrongly. And variance is the tendency of algorithms to learn random things, like learning let's say, some offsetters, learning some random values which are really offsets, and you don't really want to generalize on the basis of those. For example, let's say we have this, and the left one is if we fit this model, which is almost a straight line. This is the underfit because it has a high bias. And if we talk about the right one, it is overfitting model because it has a high variance and it fits um, all the training examples perfectly. But having such a model will not work when we have a different new data set, and it's not going to work as efficiently as the model which is in the middle. And this is a model which is just right, and this is a model which neither has high bias nor it has high variance. So this is like the perfect model, which not a perfect, but this is a good model which is um, going to memorize as well as do the generalization for the new data set as well. So this was about models, like different kind of models, different kind of use cases. So once you have developed a model depending on your use case, and now you have entire model working on your laptop, the next step is you want to put those models into production. You want to make sure that your awesome model, awesome machine learning or deep learning model is available for the outer world, and they can use it. They can send the data and get predictions out of your model, because you don't really want to keep your model limited up to your laptop. Yeah. So what we use at booking.com, we use the TensorFlow library, which is a library for different machine learning algorithms. It's basically a framework by Google. We use TensorFlow models for production. We do model training in Kubernetes, and Kubernetes is a orchestration platform for managing containers. So what we you do is like container is like virtual machine, like it's a virtual server that you create on the top of your any physical machine that you may have. And what we do is we create a pod, which is combination of one or more containers, and we run the training script on a pod. So we have a training script which was running on your laptop, and now we're going to run that same training script on a pod, which is a container this time. And the next thing, we need to have logs from this training script so that you can have a look at it how your models are training in the containers. So we export the logs to a storage. It may be a Hadoop file system, or it may be a network file sharing. It depends on your use case. And next thing is this is a really good thing. Like pods can also use the GPUs, and using GPUs really enhances your training speed. It helps in completing your training scripts in like a few minutes, which maybe you're spending like a few hours on your laptop. So it really speeds up the process of training if you use GPUs. And GPU support is in alpha in Kubernetes since their version 1.3, and I think they are into 2 point something model right now. I'm not really sure about that. Um, Next is, yeah, it works fine. It's been working fine for us so far. We have been using this kind of model training in Kubernetes to make sure that our models are being trained in the containers instead of just our laptops. And another thing is we can also visualize the training process using TensorBoard. So TensorBoard is like a visualization tool by TensorFlow, which integrates well with the TensorFlow. Um, so this is like, for example, we have three different models, A, B, and C. We can see that after multiple iterations, our model A is not really converging. It's not converging at all, actually. So that tells us that this model is not good. We can't really do anything with this because this model is not even converging. Like the loss, the y-axis is loss or error, and we can see that the error is not going down. So we know that this model is useless. Um, Now we can see the model B. We can see that it converges well, but after some time it just stays the same. Like the loss or errors remain the same. So we also know that this model is better than A, but it's not as better as C. As we can see that in case of C, it keeps converging as we increase the number of iterations, and that's the kind of information that you can get when you are using TensorFlow. You can easily visualize the training process and know if there is something going wrong with your model. And this is a really powerful way of debugging your model, because if you code up a model and if you find out that your model is not even converging, this is a nice indication that there's something wrong with the model, and you can go back and check your implementation. So this was about running a training script on containers. But what if you need to train your model multiple times? Like let's say you have a model which you need to train daily, train weekly, or train monthly. Um, what we are doing about that is we have Uzi workflow or a cron job, which starts one off job to train a model. So we had one training script on containers, and now we have a cron job which is going to start that script multiple times according to whenever it is scheduled to do that. Like if it's a daily cron job, it's going to run that training job in containers every day at about your time that we set in the cron job or in the Uzi workflow. It also so the thing is, when we run automated training, we need to be sure that we have some automated health checks, because when we were just doing the model training on containers, we had the way of visually seeing the training process. But this time, since it's going to run at any time, like we are not going to be sure when it runs, or we're not really going to be there when the training runs, we need to have automated health checks to make sure that all the model is doing good, and the loss is at the optimal value, and all these things. What we also do is we create a meta file with all the metrics, and we put that meta file into the same model, like the trained model. We package this meta file with the trained model so that it's easy to debug the model whenever something goes wrong, or if we just want to see which model is deployed, or if it's a correct one or not. The meta file really helps us in debugging that. Next, if everything is good, we deploy the model. Or if there's some problem with this entire workflow, which means that maybe the one-off job fails, or maybe the automated health checks are not successful, or maybe the metadata file is not created. In such a case, we inform the owners of the model to have a look and figure it out. The next step is to put your trained model in production. So first of all, let me recap. So first of all, we were just talking about the models, and you were training your models in on your laptop. Now you have the ability to train the models in containers, and then you also have the ability to schedule the automated retrainings of your model. And the next step is to deploy your model so that people the outside world is able to use your model to get predictions. And let's talk about how we do it at booking.com. So first of all, we use containerized service. Similar to what we use for training, we use containers for running the training script. We use containers for serving the models as well. So what we do is we expose HTTP API for predictions. So basically, when a container starts, we have to download the model from Hadoop service or MySQL or wherever we store the models. We download the models on the containers and then start a WSGI server, and that server is able to now get request as HTTP API, and then use those parameters that it gets from the request on the model, and get back the predictions, and return the JSON response as any normal HTTP API. So it's stateless. How we developed our containers is that we don't store any kind of state in our containers, and all our containers are stateless, which means that there's no state which is directly being stored on the containers, which also gives us flexibility to easily scale up and scale down. So it also is easy to load balance, because once we have the stateless app, it gives us power to send the request to any of the servers, because they are not saving any state. So that means they don't really have to be different from each other. So they are all the same, and we can easily load balance. And we can also easily scale, easily kill the containers, or create on demand. So let's say we have huge traffic coming up, we can easily spawn new containers. And if we see that, okay, the traffic is not high now, we can easily kill some of the containers to save our resources. Next is resilient. So Kubernetes is really resilient. It's really reliable in terms of how we manage the containers. So we're making good use of this technology by Google right now. So prediction time. Let me talk about this. Let's say we have n number of instances to predict. This is the time that it's going to take. Request overhead plus computation time to n. So request overhead is the time that request takes, and the computation time is the actual time that is being taken by the model to predict n instances. And in some of the cases, when we have really simple models like simple logistic regression with not many features, we see that request overhead is going to be a lot more than the computation time, because the computation time is the actual time taken by the model to predict. And if we have a simple model, the computation time is going to be very low. And in that case, the request overhead is going to determine the prediction time. It's going to be dominant. So now we are onto the part of serving predictions, and now we want to optimize for latency. And latency means the amount of time taken to to predict one data set, to return one prediction basically. What we can do to have better latency, this is simple. Do not predict if you can pre-compute. And this is in some cases come really handy, because in some cases if you can already pre-compute the results, you don't really need to predict on real time. You can also reduce request overhead by using better type of data. Like you can send gRPC instead of JSON, or you can improve how your firewalls work to make sure that you have better latency and you reduce request overhead. You can what you should do for improving the latency is that you should always predict for only one instance. So this is obvious that if you have multiple instances, it's going to take more time. And if you predict for only one instance, you're going to get a better latency. Again, this is another trick that you can use, quantization. You can lose some of the data to fix, to sort of typecast the integers to 8 bits. And so your CPU can now handle 4 times more data, 4 times more computations at the same time. And these are some TensorFlow specific tricks, which are like freezing and optimizing for inference. Optimizing inference is like dropping some of the nodes which are not going to be relevant for your output. Next is optimizing for throughput. Throughput is the amount of output that you can get in per unit time. And how you can optimize for throughput is, again, don't predict if you can pre-compute. Always keep the pre-compute results and return if you can do that. But it's not always possible. So what you can do is you can send batch request, which means like you collect the request like in thousands or 10,000s of batch, and then you send those requests at the same time. And that helps you in decreasing the request overhead, because when you make 10,000 requests for 10,000 predictions, you are going to have request overhead for all those 10,000 requests. But if you make only one request with 10,000 predictions, you are not going to have that request overhead, and you can optimize for more throughput, more output per unit time. Or you can also use the parallelization of requests to get more output per unit time. So we're almost at the end of the talk. Serving deep learning models, this is how our infrastructure looks like. We have on the right side, as you can see, we use Kubernetes to create TensorFlow HTTP service, which is having a load balancer, and then load balancer handles the request by online clients, which is like the real-time predictions, and offline clients, which may be Uzi workflow or cron job, which is requesting the predictions from our service and storing into MySQL or Hadoop file system. So yeah, that's all I had. Do you have any questions?
I don't have so many experience, but when you talk about network, it's like talking about Bayesian networks. Is the question.
Your voice is not clear. I don't understand.
Bayesian networks is like a technique, a statistical technique to create a scoreboard. Or are you using techniques like Bayesian networks? Okay, I need to write it maybe. ¿Puedo escribirlo? Okay.
Sorry, your voice is not clear. So I have given you Twitter, my Twitter link. You can tweet to me, and I will be happy to take any of your questions that you have. I think your voice is cutting down on the video. So yeah, if you have any questions, I go by Sahil Dua 2305. on Twitter. You can
Okay.
reach out to me and
Perfect.
with any questions, and I will be happy to answer those.
Okay, I think he's going to write the question in Twitter, so wait for it.
Yep.
In the meantime, does anybody else have a question? I can translate that for you if you want to. Sí, lo puedo traducir si quieren, de todas formas. ¿No? I think they're intimidated. Here's a question for you. What's the difference between machine learning and deep learning?
Sorry.
What is the difference between machine learning and deep learning?
Okay, that's an interesting question. So, deep learning is a subset of machine learning. Machine learning is, in general, making machines learn from the existing data and applying that learning to new set of test data set. Let's say. But deep learning is a subset of this machine learning in which we do the same thing, but we use deep networks, like we use deep layers, like we use multiple layers. So we don't really use all of our features directly as we do in other machine learning models like logistic regression. What we do is we create hidden layers, multiple hidden layers. Using those features, we compute that multiple times, we embed those layers together, and then we finally predict as a part of a final output layer. So this is deep learning is really a subset of machine learning. It's not really like there's not much difference. So machine learning is like a bigger sort of superset of deep learning. Yeah. Okay.
Any other question? No? Aquí. Ok, dime. ¿O quieres venir? Es que creo que no se escucha muy bien si la hacemos de lejos. No sé por qué. Un aplauso, por favor, para que se anime.
Thank you.
There's another question.
What is the relation between the intelligence artificial with all the page? Sí, uy, ya hablando.
Ya se cortó. Ok. Pues ya se cortó. Ya ni modo. Todas sus preguntas por Twitter seguramente se las va a responder de todas formas, ¿no? Sí.
Les puse el contacto de Twitter, ¿no? Entonces, cualquier pregunta le pueden...
Sí, cualquier pregunta le pueden mandar su pregunta a Twitter y ya, con eso. Bueno, pues esta es la plática que termina antes de la hora de comida, o sea, tenemos un break para comida y sí.
Nada más le quiero decir que esta es una gran plática, es una plática que va más allá de lo que pueden encontrar ahorita en la literatura, ¿sí? Todo lo que es credit scoring y todo lo que es scoring basado en deep learning es importante, ¿sí? Todos y cada uno de ustedes ahorita están por los bancos, si tienen una tarjeta, están evaluados estadísticamente, ¿sí? Entonces, esta plática es de gran importancia. Así como está planteada, difícilmente van a encontrar referencias tan prácticas y tan bien explicadas como ahorita, ¿no? Nada más les quería comentar al respecto.